Well, welcome everybody. Thank you for joining today. I hope you can hear me all right. If not, then Aizamal, please scream and I will try to speak louder or adjust my setup here. So let's get started. Today we will be talking about Beam and Flink and why you want to use them together and how you get started to using the two. And of course, also how that stuff actually works, because these are two different systems, and how can we make them, put them to effective use. So our agenda today, a little bit more detailed. So basically we have 5 steps. I'll try to keep it short, I know we don't have a lot of time. So we'll start off with a general introduction to Beam. Then we talk about Beam, Flink, and differences. Then we'll talk about the Flink runner, which is basically the translation part in Beam that does the Flink translation. And there are 2 modes, a classic and a portable mode. And I'll explain to you what that means to you and how those 2 work. And then in the end, I will show you finally how to get started using either of these 2 runners. So a little bit about myself. I'm a software engineer and consultant. I work as a PMC member and committer in both project Apache Beam and Flink. I've worked in the past with Viverica, the company that is still behind Apache Flink. I've worked with Google and Lyft on Beam and Flink. And yeah, nowadays my focus is really Beam portability, so multi-language support in Beam, and of course the Flink runner. And that's enough about me. So what is Apache Beam? I know you probably already know that, so I try to keep it short, but for those new to Beam, I try to give you maybe a little bit different perspective than you usually hear. So it's of course an open source project. It started much earlier in 2016, but it became an Apache project back then. And it's for large scale data aggregation, analytics. And in my opinion, there are 3 reasons why you would want to use Beam. The first reason is that it has a unified API for batch and streaming. In these days where we have still a lot of batch jobs, obviously, but more and more streaming jobs, I think it helps to have a unified API which allows you to write your data processing job once and then basically just switch between batch and streaming. I think that's very convenient. But of course, that's not the only reason. Second reason is you can use a programming language of your choice. Now, you can't use any programming language, of course, only the ones supported. But we have currently, I'll show you, Python, Java, Go, and more. So that's number 2. And then the third reason why I think Beam is interesting, because you can swap out the execution engine. So in this talk here, we are specifically talking about using Flink, but just remember that you could also use Google Cloud Dataflow or Spark to run your Beam jobs. So let's look at the unified API a little bit. So in other systems like Flink, Spark, we have a batch and streaming API, and sometimes also like a API for relational queries. Same in Spark. In Beam, we have just the pipeline. Now, I should mention that the pipeline is quite powerful, and it can also host relational elements. We'll get to that a little bit later. That's why there's a star. But basically, you have to learn only one API, which is kind of nice. So the API is called the pipeline API, and a pipeline is basically a series of transforms that always yield a P collection. So a transform has an input and an output. There's a special kind of transform which doesn't need an input, which is basically like a source that you know from other systems. And yeah, and that way you construct these graphs, and these graphs can really be parallelized efficiently, and you can do a lot with them. So I showed you this mini graph before. Of course, the graphs can be like very, sophisticated. And yeah, I mean, the only rule is you cannot have cycles. That's not possible. But other than that, you can have arbitrary complex structures. And how does that look like from an API perspective? I'm using the Java API here. So we have the pipeline object, basically, that holds our pipeline definition. And then we just do on the pipeline, first, when we don't have any P collection, we do an apply and use a transform, and then we get a P collection here. Here you can see we get P collection 1. You can see in the picture also the blue. I don't know, can you see my cursor? Maybe you can see my cursor. I think so.
Yeah.
So, oh, great. Okay. So, and yeah, you can do that again. You can use the P collection 1 as an input for a transform and produce another P collection. And of course, you can also create entirely new P collections like this P collection 3 and join them together and so on. So this is the basic mode of thinking that you have to learn. And in the end, you just run the pipeline, just do like pipeline run. But what do you actually do with these transformations? So in Beam, I think Beam has a really elegant design. Within Beam, there is like the notion of primitive and composite transforms. In the end, composite transforms always expand to primitive ones. So we actually only have to, make sure from the perspective of someone who implements a runner for Beam. A runner is the part that translates to an execution engine. We only have to make sure that we know how to translate the primitive transforms. And these are like read. So you can, for sources, basic for reading data. We have pardo, which is our general weapon to process data. And then we have group by key for, obviously doing some key related groupings. And we have window assignments and flattens, which like union, which says combine streams. So that's all we need. So that's, I think, really elegant from an implementation perspective. But how does it work? So if we have, if we wanted to do a word count, which is like the stereotypical example, but I still want to do it. So we have a list of words to be or not to be, and we want to count how often each word occurs. So obviously, the word to and the word be is, double, contain double in that, sentence. So what we do is we basically would do, we would use a pardo to assign ones to the keys, and then we could use the group by key to group all the keys, unique keys, and their values. And the values are like the ones that we assigned before, right? And then finally, we can use again a pardo to sum them up. So in Hadoop terms, this is called like map, shuffle, and reduce, for those who are familiar with that. Okay, so how does the same example look in the Beam API? And I deliberately put this example to show you how, what the difference between composite and primitive transforms is. So we mainly have, primitive transforms here. And basically what we do here is the same as in the previous slide, but in the API. So here we have the source, the read operation, and then we assign, we read the data, we get the element here, we assign a 1 and create this key value object, and we output this object. And we can always see the types here. So input type, output type. So we start with string, then we have the key value. Then we do group by key. And finally, again, another pardo to sum this up. This is really, this is very powerful, but it's also kind of not very readable. So you don't always need to do this. Beam has already like these composite transforms included. So instead of writing what we just saw, we can just shorten this to use this map elements function, which then just maps each object to become this key value input and the count 1, and then apply the sum integers per key. And that's essentially a composite transforms, but it really later expands to the example that we saw earlier. And we even have more composite transforms that we could utilize in this example. So it can actually be as simple as, count per element. So if you know your Beam library, that can be very powerful, and you can write programs really concisely. Of course, I mentioned that Beam supports multiple languages, so we can do the same in Python. We can use lambda functions in Python here. So here we don't have a key value object, but we would just use tuples, and the first element in a tuple is always the key. So here we assign the ones to every word. Then we again group by key, and then we extract the key here and sum up all of the values. And again, this can be even simplified by using this combine per key function and or transform and supply the summation function that is included in Python. Anyways, now that you have a feeling of how the Beam API works and how to use it, I want to give you the more complete picture. So we have this API implemented in Java, Python, and Go, and Scala. And we also have SQL support, which of course doesn't use the pipeline API because it's SQL. But what is important is that you write once in either of these languages, and then you have this sort of universal pipeline definition that is a standardized format. And then the runners, which are basically the component then which that we have for every execution engine, then translates the pipeline to make it ready to execute on one of these backends. So we have Flink, Spark, Samza, and of course Google Cloud Dataflow, and others. So I hope that this is clear now that we have this basically language abstraction which allows you to run with different execution engines. So why use Beam and Flink? First of all, what is Flink? Some of you probably know Flink. If you go to the Flink website, it describes itself as stateful computations over data streams. And I think that's a pretty good definition, because Beam is a batch and streaming engines, but under the hood, it is, its native execution model is to stream data, even if you batch process data. Yeah, it has obviously very powerful features like managed memory, exactly once, checkpoints, save points, and many of the same, let's say, semantics that Beam has in its pipeline model. And we haven't seen the whole pipeline model yet. That would take too much time, but I tried to assemble some of the common features. So of course, batch and stream processing, we have event time, processing time. So you can differentiate in your whether you want to use the actual time now or the time contained in your data. You have watermarks, which are again connected to event time and are both a concept in both systems. We have then also timers and state, of course, windows and triggers. But actually, it's not that important to mention, but Beam has its own window and triggering. That's just something to keep in mind. So I have this list. I'm not going to go through this list. I created this list to differentiate a little bit further. So we have one thing to mention maybe is that Beam is not a full execution engine. it's more like an execution abstraction. I think that's clear. I mean, we have a way to run also the pipelines in Beam, but it's not meant to be like a really scalable, full-blown execution engine. And that's why we have the runners, which translate everything for the execution engine like Flink. So yeah, I'm not going to go over this. Maybe later if somebody has a question about that. You have the slides on GitHub. You can check it out. But you should probably listen to me anyways. So why should you use Beam with Flink? Well, you have the advantage of having a unified API. You have also much more supported languages that I already mentioned. You have very powerful execution engine, which is Flink, and you have a full compatibility. So you get all the power of Beam. There are really no limitations. But you can also switch to Google Cloud Dataflow or Spark or other runners. And there's some features that are only present in Beam that you don't natively get with Flink, which, for example, is side inputs. That's also, again, probably too much for this session. But yeah, and cross-language pipelines. So I'll go over that later. The option to use Java transforms within Python, which can be really useful. So now let's talk about the Flink runner. So again, the runner is the component that translates the pipeline for the execution engine and manages the execution. We have to understand that there are historically, there are basically two versions of the runner, which I'll show you later. It's actually not that big of a deal, but I just wanted to explain you a little bit how the evolution of Beam became, and to also get you a better understanding what really happens when you run a Beam job. So in the classic runner, we only have Java, Scala, and SQL support. And if you look at the classic model, basically everything is tied to Java. We have coincidentally all our execution engines that we support in the open written in Java. So basically we couple them directly with the pipeline definition in Java and all the auxiliary code that we use to execute the pipeline. And that sort of makes it kind of easy to write a runner, and we don't have to care so much about an abstraction when we execute the pipeline. So what we do basically is we take the pipeline, we have a bunch of translators, and we result with a Flink job. We have some helpers in Beam. So we run actually Beam code inside these Flink operators. It's not only native Flink operations, but of course we try to use native operations whenever possible. So again, if you look from it from a say runtime architecture perspective, you have your SDK, your Java SDK, you have your runner, the Flink runner in our case here, and you just submit your job. The runner just submits your job through the Flink REST API, and then you have like a Flink job, native Flink job running, which has some Beam code, of course, inside. So that's great. And if you only want to use Java, then that's a great way to for Beam to operate. But we also wanted to support other languages like Python, Go. And for that, we have to run Python code because we wanted native Python to be supported. We didn't want like some subset of Python to be supported, to be only supported where some of the libraries that people use wouldn't work correctly, like TensorFlow, because they use native code. And yeah, most solutions that build non-native translations usually have like inherent limitations. So what did we have to do? We had to take the old model and arrive at a new model where, of course, not every runner managed like Python execution and every language figured out a way to run eventually in the end, because that would be very inefficient and cost us a lot of time to solve this problem. And this is, yeah, you can see it here with all the translation path if we were to build like a custom solution for all these languages and all these runners. So of course we were smarter like that. So we created the runner API, which basically holds the which holds the pipeline. And we also create an execution layer, which is called the fun API, because you can guess it's a lot of fun. And so this layer is basically what sits between the language process and the execution engine. And the beauty of it is that it only has to be written once, and then just every SDK integrates with it. So in terms of translation, because I showed you earlier the primitive transforms, and it doesn't matter if you don't remember them, but we had to change a little bit of these. And yeah, just to give you an idea what changed here, I listed these here, but yeah, let's look at what that actually means. Like, because there's executable stage here, what does that mean? So that's actually, like, usually when we have a Pardu, we would run it in Java, right? But now we have maybe Python or Go, so we have to have a different way to run it. If we look at the architecture, there's a lot here, but I'll explain to you. So we still have the SDK where you write your job, and what we then created was a way to submit your job to the job service. Job service is also basically it's an abstraction where, how Flink has a web interface, right? And Spark has one, and Dataflow has one. But we wanted something independent of all these runners. So the job service is where you manage your jobs and where your artifacts for your jobs are staged, so that during runtime we can retrieve all the Python dependencies, all the required files to run your pipeline. So the job service then has the actual runner, and the runner submits then again the job to the Flink cluster. And if we have like a group by key or a flatten, which is like a union, we can still run these like natively in Flink. But whenever we have an executable stage, which hosts our parallel do operations, then we actually start an external process called the SDK harness, and every SDK has one. So we have one for Python, Go, and Java, and yeah, the harness, it bootstraps through this factory here, which retrieves the artifacts. It's not that important, but important thing is that it communicates through the fun API with the Flink operator. And you might ask now, isn't that too expensive if you do it for like every function that you run in Python? Then you have to send the data over, and isn't that too expensive? Well, I get to this actually after this slide. But the SDK harness is actually, like I mentioned, it's just a process, and by default we run it in Docker. But you can run it process-based on the same machine, not in a container, or you can also have an external worker pool, or you can run it embedded. This only really works for Java, but it's helpful for testing. And the important thing is that you have full, what's full introspection into what happens with the SDK harness. So of course, this canard has like a control, a data channel, a state channel, a progress channel, but it also does logging. So when you have an error, anything bad happens, you always see an error message, which is really good, because the worst thing is having like an external process, which you don't know what it does. But in Beam, you have full control of it. And yeah, these are the channels that the SDK harness is used to communicate. In practice, you don't have to worry about that too much. But what I wanted to tell you earlier was, when I talked about efficiency, was pipeline fusion. So what we do is we combine as many transforms that you write into a single executable stage. And then we run them all together. So if they share the same input and they build on top of each other, they can be executed in the same environment. And yeah, if you look again at this picture, you can see now here in the SDK harness, you have these Python transforms which run in sequence. Of course, they could be also more complex, the graph here. But the point is we minimize the cost here of sending data. And yeah, probably somebody will ask about how expensive it is. We had actually estimations that it only costs about 10% of performance, but it depends on the use case, of course. It could be actually much lower if you are if you don't perform heavy computation, and if you might be I/O bound in a different part of your pipeline. Anyways, so now that we understand a little bit better how this stuff works, I'm happy to answer a question, of course, afterwards. Let's add another cool feature that we can now do with this architecture. So here we have just Python transforms, right? But I mentioned that the abstraction of the Fun API works across languages. So we can actually introduce a new component called the expansion service. And this is something really cool, because here we can actually say, when we write, for example, Python jobs, we can say, I want to use the Java Kafka I/O, for example. That's one of the first transforms we did. And because Python doesn't have good Kafka support, that's actually quite useful. So what happens then is that during pipeline creation, the SDK sees that you define your Kafka I/O, and that Kafka I/O is marked as an external transform. And then the expansion service, which exists for every SDK also, basically returns all the Java dependencies which are necessary and places the Java transform in our pipeline definition. Again, the pipeline definition is language agnostic, just what's inside of the actual transforms can be language specific. So then we go to stage that job with the Java Kafka source, and we might end up here with this executable stage, which then runs a series of Java transforms, as well as we have the other stage, which runs the Python transforms. Okay. So I hope that was not too complicated. I want to spend the last minutes of this talk telling you how to get started with all this. So generally speaking, I could include some links here, which should be clickable in the PDF. There's the Beam documentation, and there's also a dedicated getting started page, which tells you for every language how to get started. Then also you should be checking out the Flink runner page, which tells you about special options that everything basically you need to configure the Flink runner, and also special options which allow you to set some Flink settings which you might want to adjust. So how do you write Java pipelines? Again, there's the quick start. You can do it, but essentially you have this Maven quick start. I believe we have one for Gradle as well. You import it directly into IntelliJ. You set the runner. We usually do that by our arguments to your pipeline, to your main function, basically in Java. So we say runner, Flink runner. If you don't specify any runner, then it will be the direct runner, which is like the Beam included one, which is not really fast or anything, but it's helpful for testing. But you can also use just the Flink runner for testing locally. And if you specify a Flink master, you can actually submit that job to a Flink cluster, which you have to start separately, of course. But again, if you don't supply it, then it will start a local cluster automatically. So I just wanted to give you like a little blueprint that I always start off when I write a Beam pipeline. So what is really helpful is when you define the job is that you use this pipeline options factory from args and pass in the args from your main method. That allows you to parameterize your job, like I did with this Flink runner flag in the previous slide. But so you create your options, but you can also set then options in the code itself. So you can set streaming to true if you don't want the auto streaming switch, if you want to explicitly enable streaming. You can also hard code the runner, but yeah, I don't know why you want to do that, because you could also switch to a different runner more easily with the runner flag on the command line. So again, then we have our pipeline and we run it. It's pretty simple. So for Python, again, this is also online, but condensed summary here. So you want to create a virtual environment like Python dry, preferably, because Python 2 is end of life. And then you pip install Apache Beam. It's really as simple as that. And you write your pipeline. And again, you do like runner, Flink runner to run with the Flink runner, and Flink master if you want to submit to a cluster. Now you might wonder, I saw this like in the slide with the overview, I saw these components, and yes, I mean, if you use the Flink runner, it should work by default. If you want to get more involved and start your own job server and so on, like I showed you earlier, then yeah, you have to consult the documentation. But really, just using that with Python will get you a running Flink job on Python. Granted, you have Docker installed, but that's something we all have nowadays. So the blueprint, again, import for the program itself. We do import Apache Beam as Beam. That's always handy because Apache Beam is so long. And then we create the pipeline options. And by default, it will also use the arguments of your program, the command line arguments, and include that in the options. So everything like the runner will be already configured. And then we use the syntax with Beam pipeline. We pass on the options as P, which then automatically runs the pipeline when this block is finished. And yeah, we usually use parentheses here to ensure that we don't get problems with the Python spacing, and so we can nicely align everything here. Yeah, basically, we had this example. Maybe you want to try out this after this webinar and see if it works. And yeah, so I have a little section also on SQL, which I'll just shortly skim over because I want to leave some time for questions. So if you want to use SQL, you have to add a special artifact. That's this one, Beam SDK Java extension SQL. And in Maven, you do it like this, and in Gradle like this. We have a new version, by the way, coming out 2.21 very soon. But for now, we use 2.20. Yeah, and with SQL, the way you use SQL is you first need a schema. So in this case, we have ID and a number and a name field in the schema. And then you can start actually creating rows with that schema and add values. Like here, we have the row with the values 1 and max. And then you can actually, with this P collection row, you can actually run SQL queries, which is pretty cool. So you can do like SQL transform, select a name from the P collection where ID is 1, for example. You can even do joins and more pretty complex groupings and complex SQL queries, but there was not enough room on the slide. You can also use POJOs. So if you have a class like this, myData, you could extract the schema from the POJO. So you could have POJO utils schema from POJO class. You would, as an error here, you would specify the myData class. It's not option says myData. And yeah, use this Java field supplier. And again, then you would you use that schema to work with it in the same way as we saw previously. So with that, I want to conclude. I think we have seen that it's quite cool to use Beam and Flink, and there are very good reasons for using both. First of all, the unified API for batch and streaming, then the very flexible language choice that you get with Beam, and of course, yeah, you get the robustness and speed of Apache Flink with these two features, and the ability to also switch to a different execution engine if your use case ever requires it. So with that, I want to say thank you and encourage you to visit the Beam website, subscribe to our mailing list. These are all clickable links. Follow Apache Beam and register for Beam Summit Digital. It takes place August 24 to 28. As Amel already mentioned it in the introduction, you can register for free. So you might as well do that now or after we finished. Yeah, you can follow me on Twitter in this handle, Stadtlegende. It's German. It's a German word, but don't worry about it. Yeah. So with that, I'm pretty much done, and I'm looking forward to answering some questions. Isamal, do we have any questions?
Thank you, Max. Yes, we have 4 questions in the Zoom Q&A section, if you can go there.
Oh, wait,
and
maybe
I can also read them out to you.
Wait, I think I have to stop sharing for a moment.
Mm-hmm.
Oh, okay. Okay. So we have a question from an anonymous attendee. How does Apache Beam compare to Apache Flink? What are advantages of writing your Python pipelines using Beam on Flink instead of just Flink? Well, so Apache Beam, it's not really, it doesn't matter, but it's not really called Apache Beam. We just call it like Beam Python. But so Apache Flink is a Python API that is relatively new. I think only included since the last release. And it actually, I didn't mention that, but it actually uses Beam under the hood. But it is not a full-blown Python API like we have in Beam. It builds on top of Flink's table API, which is more like a relational API. So it's a lot less flexible, but it is also a Python API, and personally haven't used it much. It might be a little bit limited for some use cases. That's all I can say about that. Yeah, so I want to use another question here. I want to use Beam for the unified API. Do we know anybody is using Beam for Flink and Spark at scale in production? Yeah, so there are numerous people who use Flink or Spark in production. One of the biggest customers or users is probably Lyft, which has, quite, don't have any numbers now, but it has a lot of events going in for their real-time pricing application built with Beam, and that Beam application runs on top of Flink, of course. I'm not prepared for this, so we have more users for sure. I mean, we have a bunch of people who are using it for in scale. We have I know that BBC, for example, uses it. There are a number of uses for sure. Maybe Aizama, you can say more about that.
Yeah, like if you're also interested to see one use case, like next week, Alibaba is also sharing their use case, and they use like Spark, Flink, and other open source technologies together with Apache Beam. And yeah, and
cool. Yeah,
eBay.
I should probably add like a powered by section next time. We have a list of companies using it. I'm just can't give you like the complete list right now. So how is the I'll try to update the slides though. How is the SQL support? Which SQL do we use? How do we define UDFs in SQL? So the SQL support is based on Calcite, and there's also support for Zeta SQL, which is a Google project. These are two SQL dialects that you can use. So UDFs in SQL, the way we use UDFs in SQL is usually, so you have the option to combine it in your pipeline definition. So you can define any kind of operation there. And as for registering UDFs in SQL, I am not really sure. There must be a way, but I'm not working on the SQL support, to be honest. But again, I'll update the slides if I find out how to do that. So then another question is, when I'm bundling a Python transform, say I use TensorFlow logic, how is that this bundled with the rest of the Java jobs for loading into the runner? Is there a Git repo that explains this type of bundling? Say Java is using Maven and Python is using setup.py and requirements text. Yes, every language has a way to, it stages its artifacts and then also has a way to install these artifacts. So if you use, let's say you use Python, then there will be basically a list environment created with the Python dependencies, which will be installed via pip. Sounds like a question that I could answer in person, but I'm not really sure 100% what the problem is there. But yes, every language has a way to stage artifacts. In a session window, can we join more than 2 unbounded tables using Beam SQL? Well, that's a good question. I might have to pass on that one. 2 unbounded tables. I'm not really sure what unbounded table means in this context. But I mean, if we're talking about session windows, then yes, we can work with unbounded data. So it's probably related to the syntax. Again, can't tell you from the top of my head right now. How is it different than Apache Crunch other than streaming support? I don't know Apache Crunch in detail, but I think Crunch built is an API layer for Hadoop, if I'm not wrong. And so, yeah, the streaming support that you mentioned here is probably a big difference. And the whole semantics, I believe, are much more flexible than Crunch way. Is it possible to use Flink connectors with a Beam job, for example, to connect to Apache Pulsar, or is there a Pulsar IO for Beam? I think the Pulsar IO for Beam is, if it's not already there, it's in the it's in the works. So I know somebody's working on it, but whether you can use Flink connectors in Beam or not, that's a great question.
300K.
It is possible, users are doing it, but it's a sort of a hack. But we have been thinking about whether we should expose this as a native concept to just be able to use Flink sources. It's not really ideal though, because we want to keep that ability to execute cross-language. So yeah, it is possible. Basically, you have to add a new translator, which then loads in the runner, which loads the native Flink source. There are users who have been doing it in some cases, but it's not, it's not supported natively. So, okay, so there's another question. So I'm on the more technical side in my firm. Business side loves the one-liners. If I ask, simply put, what is this and what will it enable? Any tips on translation work? I find myself often doing, yeah, that's I think a more philosophical question, or a really hard question I can't answer here. So I think the good idea is to start working with that technology and build something that actually is useful and that solves a business case. And then I think you have, if you manage to get approval for building like a proof of concept, then you can find out if that works, and you can convince the management that it's a good idea to invest in that technology. More questions. Can two pipelines be defined and run synchronously? No, pipelines don't share data with each other unless they use, for example, Kafka or some message queue in between. If you don't, again, the question is, I think, a little bit too involved to answer here, but generally no, pipelines are disconnected from each other unless you connect them implicitly through, let's say, Kafka or some other I/O. Some remarks regarding the unbounded table question. Okay. Unbounded joins. Yeah, I mean, joins by definition cannot be unbounded. You need some kind of bounding, and usually we do this time-based. So we define a window and then join the data for that time span of the window, or for, yeah, so either processing time or event time, or we do it, yeah, or we do it session-based, based on some criteria in the data. Can I reach out to you offline? Sure, I can connect you to people who are using SQL. Just contact me on Twitter, for example. Okay, I think that's it for now. I think we already hit the 1 hour mark. Thank you so much.
Yeah, thank you, Max. Also, reminder to the attendees that if you have specific question about your pipeline, please ask at user@beam.apache.org. And Max and other like Beam and Flink engineers, they monitor the user list, and yeah, they can help you to debug some of your pipelines or answer your specific questions. Okay, thank you, Max. It was really great having you, and hope attendees enjoyed this session. And yeah, please join our next webinars, the use case with eBay, and also the that's happening next week. Anyway, cool. I think we are good here.
All right.
Thank you so much.
Thanks for having me. Hope you enjoyed the session.